Time travel. It's a concept that has fascinated humanity for centuries, inspiring countless works of fiction, from the tales of H.G. Wells to the intricate plots of modern science fiction films. But beyond the pages of books and the screens of cinemas, one question persists: is time travel scientifically possible? Today, we're going to dive deep into the science behind this intriguing question, exploring the theories, the challenges, and the possibilities that lie within the fabric of time itself. Segment 1: The Nature of Time. Before we can discuss traveling through time, we need to understand what time is. Time, in its simplest form, is a measure of the progression of events from the past, through the present, and into the future. It's the fourth dimension in our universe, complementing the three spatial dimensions we're familiar with: length, width, and height. But unlike the spatial dimensions, which are easy to conceptualize, time has always been more elusive. We experience time as a continuous flow, a river that carries us forward, unable to stop, slow down, or reverse its current. But is this flow of time an absolute, unchanging phenomenon? Or is there more to it than meets the eye? Einstein's theory of relativity gave us a revolutionary new perspective on time. According to relativity, time isn't the same for everyone. It can stretch or contract depending on your speed and gravitational field. This phenomenon is known as time dilation. Imagine you're on a spaceship traveling close to the speed of light. To you, time would seem normal, but to an observer on Earth, your clock would appear to tick more slowly. In essence, you would be aging more slowly compared to someone on Earth. This isn't just a theoretical idea, it's been confirmed through experiments involving fast-moving particles and even precise atomic clocks on aircraft. Segment 2: Time travel to the future. Let's talk about the future literally. If time can be stretched and manipulated, could we travel to the future? The answer, surprisingly, is yes. Time travel to the future is not only possible, but it's already been done, albeit on a very small scale. As mentioned earlier, time dilation occurs when objects move at a significant fraction of the speed of light. The faster you move, the slower time progresses for you relative to someone who is stationary. This means that if you could travel close to the speed of light, time would pass more slowly for you than for someone left behind on Earth. When you return, you could find yourself years, decades, or even centuries in the future, depending on how fast and how long you traveled. This concept is beautifully illustrated by the twin paradox. Imagine a pair of twins. One twin stays on Earth, while the other embarks on a journey through space at near light speeds. Upon the traveling twins' return, they would be much younger than their sibling who stayed on Earth. In effect, the traveling twin has leaped into the future. Another way to travel to the future is by taking advantage of strong gravitational fields. According to Einstein's general theory of relativity, time slows down in the presence of gravity. This effect, known as gravitational time dilation, has been observed in places like the event horizon of a black hole, where gravity is so strong that time nearly comes to a standstill. If you were to orbit near a black hole at a safe distance and then return to Earth, you might find that many more years have passed here than for you. Segment 3: Time travel to the past. But what about traveling to the past? This is where things get tricky. While traveling to the future has a solid scientific basis, the idea of journeying back in time opens a Pandora's box of paradoxes and challenges. One of the most famous paradoxes is the grandfather paradox. Suppose you could travel back in time and meet your grandfather before he met your grandmother. If you were to prevent their meeting, you would never have been born. But if you were never born, how could you have traveled back in time to begin with? This kind of paradox suggests that backward time travel could lead to logical contradictions, creating a complex web of cause and effect that might be impossible to untangle. However, some scientists have proposed solutions to these paradoxes. One idea is the concept of parallel universes or alternate timelines. According to this theory, if you travel back in time and change something, you would create a new timeline, a parallel universe where the new events unfold differently. Your original timeline would remain unaffected, and you would continue to exist in this new reality. Another intriguing possibility comes from the study of closed time-like curves, CTCs. These are theoretical paths in spacetime that loop back on themselves, allowing an object to return to its own past. CTCs are permitted by the equations of general relativity, but whether they could exist in our universe or be created artificially is still an open question. Wormholes, or Einstein-Rosen bridges, are another hypothetical means of backward time travel. A wormhole is a tunnel-like structure connecting two separate points in spacetime. If one end of the wormhole were accelerated to near light speed or placed in a strong gravitational field, it could experience time dilation relative to the other end. This could, in theory, create a time difference between the two ends, allowing someone to travel back in time. But before you start packing your bags, it's important to note that wormholes are purely theoretical at this point. They require exotic matter with negative energy to remain stable, something that has yet to be discovered or created. Segment 4. The Challenges of Time Travel. Despite these fascinating possibilities, time travel faces enormous scientific and technological challenges. The energy required to create and sustain a wormhole, for example, is far beyond our current capabilities. Even if we could generate the necessary negative energy, keeping the wormhole stable and traversable presents another set of problems. Theoretical physicist Kip Thorne has suggested that any attempt to use a wormhole for time travel might cause it to collapse or close up, making the journey impossible. Moreover, the very concept of time travel to the past raises questions about the nature of reality and causality. Would the universe allow time travel, or are there fundamental laws that prevent it? Some physicists, like Stephen Hawking, have proposed the chronology protection conjecture, which suggests that the laws of physics might conspire to prevent time travel to the past, ensuring the consistency of cause and effect. On the quantum level, time travel also encounters significant obstacles. Quantum mechanics introduces the idea of uncertainty and the potential for multiple outcomes, which could complicate the creation of a coherent timeline. Additionally, the notion of quantum entanglement, where particles are linked across time and space, raises further questions about the nature of time and how it could be manipulated. Segment 5. The Philosophical Implications. Beyond the scientific hurdles, time travel brings with it profound philosophical implications. If we could travel through time, what would that mean for our understanding of free will, destiny, and the nature of existence? Would the future be set in stone, or could we alter it? If the past could be changed, how would that affect our identity and the continuity of history? Some philosophers argue that time travel could challenge the very notion of personal identity. If you were to meet a past or future version of yourself, would that person truly be you, or would they be a different individual altogether? And if we could change the past, what would that mean for our memories and the experiences that shape who we are? Moreover, the possibility of alternate timelines raises ethical questions. If every decision we make could create a new universe, what responsibility do we have for the consequences of our actions in these parallel realities? And how would we navigate the moral complexities of interacting with different versions of ourselves or others? Segment 6. The Future of Time Travel Research. So, where does that leave us? Is time travel nothing more than a fantastical dream, or could it one day become a reality? While the challenges are immense, the pursuit of time travel continues to inspire scientists and researchers around the world. From exploring the nature of black holes and wormholes to studying the quantum mechanics of time, the quest to understand and possibly harness time travel is far from over. In the meantime, the concept of time travel serves as a powerful reminder of the mysteries that still surround the universe and our place within it. It challenges us to think beyond the limitations of our everyday experience and to consider the deeper, more fundamental questions about reality, existence, and the nature of time itself. Time travel may remain in the realm of science fiction for now, but the journey of exploring its possibilities continues to expand our understanding of the universe. Whether we ever manage to break free from the confines of time or not, one thing is certain. The pursuit of knowledge, no matter how impossible it may seem, is a journey worth taking. Thank you for joining me on this exploration of time travel. If you found this discussion intriguing, don't forget to like, subscribe, and share your thoughts in the comments below. And who knows? Maybe one day, we'll look back on this moment from the distant future or perhaps even from the past.